All right. Well, if folks join along the way, that'll be great. We can get started now. So thank you everyone for joining me this morning or this afternoon, depends on what part of the country you're in. Today, we have a alum from the GISBP Master Program. So Brad is here to talk about some of the work that he does and has been doing. This is a continuation, I guess, of our first talk that we had with Ginny about a month ago. She was talking a little bit about cartographic design, visualization, focusing a little bit more on maybe the print map side of things. Today, Brad's going to be talking more on the digital side with visualizations and sort of how do we scale those things. I know for me personally, and the data that we work with really large data sets, and oftentimes it's really challenging to visualize it. And it's really important for us to do that in the work that we do. So Brad's got some tips and tricks that he's going to go through and talk a little bit about. So a little bit more about Brad too. He is a senior software engineer over at Element 84. We reconnected late last year at postGIS North America. Element 84 was doing quite a few cool talks. Brad actually gave one of them, and it was a packed room. So I'm really excited to actually get to hear the talk this time because I wasn't able to hear it last time. Wasn't able to get in there. So today, what we're going to do, Brad's just going to go through, give us a little bit about his background and talk more about maps. And then afterwards, we're going to be able to have some discussion time, ask questions, and just talk. So it's pretty informal. If you have any questions throughout, feel free to raise your hand or put into the chat any of the questions, and we'll get to it when the time's appropriate. So yeah, with that, Brad, I will throw it over to you. We can get started.
Okay. Thank you very much, Chris. And thanks again for having me, and thanks to the whole GIS program here for inviting me to talk here today. I'm going to go ahead and share my screen here. Let me make sure this is up and running. All right. It appears to be for me someone yell. It's not here. So we should see a slide deck, and now it should be full screen. Chris, is that correct?
That looks great.
Awesome. All right. So the talk I'll be giving today is entitled Seeing Everything, Digital Cartography and Strategies for Visualizing Large Data Sets. My name is Brad Andrick. Really quickly, I wanted to say all of these slides are able to be found here. So feel free, go back to the recording, take a screenshot, take a picture real quick. You can find all of these slides if you want to poke around in them later, they're open. Quickly, I wanted to say, who's Brad? That's me. My name is Bradley Andrick. I'm currently an engineering manager and senior UI UX front-end engineer by long title. I work at a company called Element 84. And my background is mostly from the geography and GIS world. So I did my undergrad degree in Virginia at James Madison University, focusing on geography and environmental science. Started doing a little bit of web mapping in my first role out of undergrad in a GIS position, and realized I liked doing that and doubled down and joined the first cohort to come through the online Wisconsin master's program. I've bounced around between public and private sector, lived the startup life. I worked local government and bits and pieces in between for about 10 years now. And how I generally talk about myself, so if I'm introducing myself to someone for the first time, I usually say I'm a software engineer who deals with maps. But I like to say I'm a specializing generalist, meaning that I know a little bit about a lot of things, but I specialize in front-end engineering, but I specifically care about digital cartography. And that's kind of my skill set. You can find me at all of the places, email, on GitHub, on LinkedIn, if you want to connect. I wanted to quickly talk about the place that I work. It's called Element 84. And so we're woman owned. There's a very marketing slide for a couple of these, and I'll get into the content. But we're a woman owned small business. We're about 60, 70 people. And we work with public, private, nonprofit, mostly developing geospatial data processing pipelines. It's kind of our sweet spot. We also build software, mostly web apps these days, that help do things for the world. So one of our values is our work benefits the world, and we like to do take on projects and clients that align with that. We're also, Chris mentioned that I was at the FOSS4G North America conference. We're also, as a company, deeply ingrained in the open source ecosystem. So if you've ever heard of the Spatio-Temporal Asset Catalog, or STAC, we're kind of big players in that environment. We've helped create that specification. We sometimes host sprints to expand upon that specification. And all that work happens out in the open, which is really awesome. Like I mentioned, we mostly sit on like the geospatial infrastructure side. So that's really talking about this big shift that's been happening to go cloud native geospatial. And so we have a lot of skill sets, and I have some brilliant coworkers that know a lot more than me about scaling and software architecture for cloud native geospatial. And then we also build software. So like I said, mostly web apps these days. We've done some mobile in the past for specific, usually open source, but also clients. And here are some of those clients. If you're interested, happy to talk about these at the end more. But a lot of NASA, ESA, USGS. We've done some Microsoft. We're an AWS partner, Nature Conservancy, a lot of neat organizations out there that we get to work with. So this talk, though, what's in this talk? Again, it's called Seeing Everything, Digital Cartography and Strategies for Visualizing Large Data Sets. I'm going to really talk about two different paths here. First, counter to the title of this talk. Actually, I'm going to talk about why you shouldn't try to see everything. And then if you still feel like you need to try to see everything, I'll kind of walk up the software tier on how you might do that. So I'll talk about some techniques in the first path, and then I'll talk about some technologies in the second path. So I'd like to start by introducing a problem, and it's a problem that I've had multiple times in my career. But to frame this, I'd like to say your non-technical stakeholder wants to see where their data is on the map. It's global in coverage and it's expected to go from thousands up to many millions of points. The key words in here, your non-technical stakeholder. Those are usually the folks that are asking to see everything on the map. They download a CSV of all of their data and they think that they're seeing it on their computer, even though they're seeing a small piece of it at a time. And it's only really a problem when we get into these thousands and many millions of points. So diving into path number one, why you shouldn't try to see everything. First, it's usually not what you want to see, right? So here's the courtesy of Reddit, a map of every pub in the UK. Maybe it's not so helpful. Now, could we make this better? Sure. We could turn these into smaller points and things like that. But still, it's really not that useful to see everything just thrown onto a map. Also, it can be really slow, right? Lots of data means things slow down, so we need to be aware of that. So what do you do about these things? Well, you don't let them see everything, at least not the raw data, the underlying data. So the first technique that I'll talk about is pretty simple. It's just scale visibility. So when you're zooming in, things start to appear. It's really as simple as that. You can see the context of this park in the middle of this map. And when you zoom in, you can again frame yourself with that park and you see there's a bunch of parcels showing. The problem is if that park wasn't there and you needed to try to figure out where your data was and it wasn't continuous, usually these parcels will be, but they'll stop at some point. And sometimes we're dealing with data that doesn't continue in the same way that parcels would. If that park wasn't there, we wouldn't know how to orient ourselves. And so that's kind of the problem with just leaving it at scale visibility alone. Yes, we get some performance gains pretty quickly from this, but you need to figure out a way to find where your data actually is before it becomes visible. and that's a big challenge. Next, I'll talk about feature simplification. And this is just taking away a bunch of vertices, simplifying it, which increases performance pretty quickly. MVT tiles under the hood are kind of doing this for you, but you can do this manually as well. You can even do this over a big data set and then spit it out simplified, and that makes things render faster. One of the challenges here, though, is that things sometimes need those vertices, like road networks, right? We'll cut across corners, so that can be a problem. But it's a quick way to gain some performance gains when you need to. Next, we kind of reach for clustering. And I like to think about this as a light switch one. So lots of built-in map libraries, you just kind of turn on clustering, bam, your problem solved, right? And it kind of is, at least as performance is concerned. But you'll notice here that the symbology is one of the cons of clustering here. So we still see our underlying single point here showing everything's clustered except for one point, which also affects your click events. So if you're going to interact with that individual point to show a pop-up, you can't do that with your other clusters. So that can be a problem. Additionally, clustering doesn't actually show you, for example, if we want to know, do we have data in Wisconsin? We can't tell that from the clusters. Probably, maybe, but we actually can't see that. And so that can be another problem. And lastly, I've actually seen clustering, the underlying algorithm for clustering by default can be a problem. So I've seen it introduce bias with a crime application that was showing where different crimes had occurred, and they used clustering to group those. The problem was that clustering algorithm was kind of showing where crimes happened, where they maybe didn't happen. So it was introducing bias for the user of that application. Next, and similar, we move into icon overlap, which is super simple, but maybe not so useful. Here in maplibre and mapbox, we can just set one parameter of overlap to true, and then bam, instant performance gains. One of the challenges here, if you notice between these two screens, the symbology is exactly the same. And so I tend to not actually reach for icon overlap very often, because if you aren't aware that the setting's turned on, it looks like data's magically appearing and disappearing on your map. And even sometimes when I've been using this with more technical stakeholders that they should know what's happening, they come back and say, hey, why is my data disappearing and reappearing on the map? So by that measure, even though it's very quick to turn on, I generally would not reach for it for the most part. There's also heat maps, which are great for analysis. I've used them in the past when I had nothing else to kind of show where things are at a high level and get those performance gains, kind of grayscale things out, and that works well enough. Problem is, these are for analysis and showing hotspots. So as you zoom in, things get tighter and tighter around those hotspots. So you don't really have a great coverage of where your data is, and that can be a problem. Aggregations, this is kind of my personal favorite. And essentially, you're just creating bins of some size and mapping the data into those bins. You can use centroids. Here I'm showing an example from an open source project that I've worked on recently called Film Drop, or the Film Drop UI. And essentially, this is a tool for viewing imagery in the AWS Open Data Registry. So you can search for Sentinel, Copernicus, Landsat, and a series of other satellite imagery datasets and see them on the map. Problem is, showing a lot of footprints on the map can be a challenge. And here we're using the H3 hex aggregations originally from Uber. You could use others. There's Google's S2, and there's also, we're using the MGRS grid aggregations at another level in here. But we're showing only 2,000 or so hex cells, but we're seeing about 17,000 aggregations shown here. And when you combine this with a color ramp, you can really see the coverage as well as the density of your data, which is really, really powerful. And I want to mention here, we're actually just using leaflet. So we're seeing 16,000 scenes. You can actually get up into the hundreds of thousands of things on a leaflet map just by using a simple aggregation like this. If you want to know more about this, because it is open source, I'd encourage you to go check it out. I mentioned the AWS Open Data Registry is really cool. And we do something with them called the Earth Search API, which is a stack endpoint where you can search through all these collections. We actually have this UI hosted free and open and available to poke around and play with if you want to check it out at the middle URL, and then the project, if you want to take a peek at the code, is there at the bottom. Next, I wanted to touch briefly on optimizing rendering expressions. It's kind of twofold here. One, I've seen times where people are using these complex markers, and maybe you don't need to use a complex marker. Just simplify the marker that you're using and you can get some performance gains there. And then also considering the actual function that's calculating your rendering time. So this is for maplibre and mapbox. But the number of sources and the number of layers and the number of vertices essentially combine to create your rendering time. So you could consider reducing the number of sources and reusing those for multiple layers, and that can kind of increase your performance there. Typically, I say, if you're having to deal with these things, reconsider what you're doing because you probably can choose something else and that's going to work better for you. Lastly, I wanted to mention perceived performance hacks. So this actually isn't increasing your performance. It's changing how your user sees that performance. So here we're showing a little Google loading spinner that takes a couple seconds to get through. So you can let your data spin off in the background, and instead of throwing your user into kind of a desert fog problem of a blank map, you can show them a graphic, just taking the same amount of time to go render your data, but it's enough cognitive load to keep their attention focused on something else while that's happening in the background. Or you could just delay these loads. So you're not actually increasing the performance, but you just are turning off data until the user actually needs to see that data. So a quick initial load for a base map is very fast, and then only load the data when you need the data. And then you can show a loading spinner and the user is recognizing they've clicked that, and that's why the delay might be happening. Path number 2. So if none of that works for you and you still want to go down the path of trying to see everything on the map, these are some ways that you can do it. I wanted to caution here that your target device is probably not the workstation, the MacBook Pro, whatever you're developing on. Usually, it's happened to me in the past where I was developing a mobile application and I had a mid to upper range Android device that I was testing on. And when we actually went to deploy that out into the field managers had bought the cheapest possible Android device that they could find. And we had not anticipated that, and so we had to deal with these performance gains in the moment. So consider where this is going, and if your device that you're running on can handle what you need it to do. Kind of the entry tier here is Canvas HTML5 renderers. Leaflet, I love it. I've used it for a long time. It's great. It's very simple. It's very lightweight. And also, if it works here, it probably will work a lot of places for the most part. But at some point, you kind of hit the limitation. When I was prepping for this talk, I kind of started thinking about, well, what's the number where you need to switch to something else? And the answer is there isn't a magic number there. I will give a rough range of where I've seen things max out, but depending on the complexities and the data that you're trying to visualize, this number is probably pretty different. But generally, I see Leaflet from very, very little data up to the thousands and maybe the low tens of thousands before things really start to stutter on you. Reaching beyond that, we move into our WebGL based renderers. So maplibre, Mapbox, openLayers, Cesium, DeckGL. These really start to push things further and further into what you can show on the map. And you can do some really, really complicated and awesome visualizations here, 3D things as well. And here you kind of start pushing up into the hundreds of thousands, even the low millions you can do with these kind of renderers. Some really, really neat 3D things, like I said. But at some point, these will also start to stutter and you're showing too many things on the map. Next, we kind of start pushing into dynamic tiles. So before I talk about this, I wanted to point everybody to a Paul Ramsey talk from 2019. You can Google serving dynamic vector tiles and Paul Ramsey, and you'll find it's his talk recorded on YouTube. So 2 talks for the price of 1. He gets into the nitty gritty of dynamic vector tiles. But there's a lot of these out there. There's Martin, which is a really fast one written in Rust. There's Dirt, which is JavaScript, and there's a few others out there, PG TileServe. I think there's one with some Python tooling now as well. But essentially here we're talking about a database, some middleware, and a client. And so this dynamic tile server should be pretty lightweight and sit as this middleware. So taking data out of your database, converting them to dynamic tiles, and then returning them back to the client. Again, for all the details, go check out this talk from Paul. I did want to throw a caution in here that vector tiles do not equal your raw data. So this sometimes can be challenging for people, but those vector tiles are doing simplification. They're usually truncating some values, reducing your precision, sometimes dropping a lot of metadata out of the actual data sets to make things fast. So think more about vector tiles as really fast dynamic base maps that you can style on demand, and less about like, oh, my data is just really, really fast and dynamic now. I wanted to touch on static pre-generated tiles. You might be saying, really? I say yes, really. So if your data is not updated often, just build the tiles. It might take a while to build them and then host them out. Vector or even good old raster tiles are still useful. And you can go into really, really big data sets because you can do all of that processing time up front and then just serve out the tiles. So I don't have a lot of time to get into this, but I wanted to throw out a bunch of words here. Go look up a lot of these technologies. PM tiles, there's a lot of cool things happening with proto maps, and then ways to create these: GDAL, TileMill, Tippecanoe, Mapnik, and then a few formats, MBT, MB tiles. So go Google around for those. And then we kind of come into a little bit of uncharted territory, at least for me until recently, of server-side maps. That is kind of like really big data, but better in a way. And I say kind of new to me. We're kind of going full circle here, because if you've been around long enough, everything used to be server side, and then we went away from that. But I wanted to talk about this a little bit in detail because it's a little different than what it used to be. So here I'm going to introduce again a database, some middleware, and a client. But I'm going to say that's a really fast database. So we're generally talking about columnar, really fast reads out of our database, because that's kind of the magic sauce here. And then instead of tiling dynamic tiles back or hosted tiles back to the client, we're actually going to serve dynamic images. So a single PNG coming back for full coverage of the map. So I want to talk about this a little bit deeper, and I'm going to call out Heavy AI. I don't work for them. I don't know too much about them as a company, but I know they're doing some cool things, and they're doing a lot of it out in the open. At least they used to be more and more. So I wanted to mention that they used to be called OmniSci, and they used to be called MapD, because you can find a lot of the older APIs that are still very, very useful by finding those names and digging into documentation. So wanted to call that out. Here's kind of the heavy AI architecture world. It's probably a lot of marketing stuff. I don't care about all of that. What I care about here is HeavyDB, which is that really fast read database, and Heavy Renderer, which is the visualization engine, specifically the Vega rendering engine that's kind of making this magic happen. So again, super fast DB middleware and a client. If we compare that to the heavy AI stuff that I'm talking about, we have HeavyDB, so our database. We have Heavy AI connector, which is kind of our API layer. And then we have overlaying these PNGs. And I was at Phosphor-G, so I still had this open source in here, but you can go poke around and figure out what's happening, which is great. Vega and Vega Lite, I just wanted to call those out specifically on a slide here. They're visualization grammars. If you aren't familiar with that, it's kind of a simple way to create a data visualization. And so you kind of define usually a data source and what you want that visualization to look like, and it'll create a lightweight one for you. Here's an example, a bad example of someone putting a database connection string password into a function. Don't do that. But you're passing in some Vega options in this simple little function here, making a connection to the database. And you can actually pass in SQL as part of that data parameter. So instead of defining a data set and having that in memory, you can let the SQL execute. That's how Heavy AI is doing it. to actually render that SVG or PNG really quickly and spit it back from this response. So what does that all mean? It essentially means we can render hundreds of millions of points on a map, which is pretty powerful and pretty wild. Now, should we be putting hundreds of millions of points on a map? I'd argue probably not that often. And it's not without its downsides. So every pan, every zoom, we have to fetch back out to the server. And even though we're talking about these really fast read databases and lightweight PNGs, we still have to fetch every single time, let that happen. And we see these flashes in the user experience on our map, which isn't great. But if the trade-off is being able to see hundreds of millions of points, and that's what you need to do, that might be an okay trade-off to have. I think there's a lot of interesting space here for making this more open for one, but playing with not needing the heavy A kind of pieces in the puzzle. So we have a lot of fast read analytical things happening. So GeoParquet is really, really exciting. Parquet format in general for fast analytical reads. Prior to giving this talk, I've been playing around with doing the same logic that I've talked about here that heavy AI is doing, but with just a simple Postgres and postGIS database that I load about 2 million points into, just enough to play with. I query that, and I've done it in leaflet and maplibre, where I have a map extent, and I take that full extent of the map, pass it over to my little node API, and say, go grab all of this from the data. So it queries PostGIS, and then it spits back my data. It formats it. This is all before sending a request back to the client, response back to the client. And then it creates the visualization grammar based on that data source, creates me a lightweight PNG. I stream that back to the client. And because I knew my source bounding box, I can just map that overlay back into that bounding box and see all of that data in one lightweight PNG. And in theory, you can just repeat that on your pans and zooms. I wanted to mention here one really cool thing that Heavy Eye is also doing. One of the problems of having a single PNG is you can't really interact with it very well. So they're mapping the X and the Y coordinates of that PNG and the click events in the browser. And they know based on what pixel you click on, how to map that to your image. And they can query the database really quickly and simulate hover events and click events as if the data was actually on the client, which is pretty cool and pretty powerful. So that's the end of my talk. Again, path one, probably what you should do first and why you shouldn't try to see everything on the map. And then when you still need to, you can kind of walk up the software tier and see a lot of things. Thank you. Open it up for questions. Happy to talk about myself, my career more, where I'm currently at, anything out of that talk. Thanks. Back to you, Chris.
Yeah, thanks, Brad. I had not heard of the OnSide before, so I'm definitely going to be looking into that for my team. We've been using a lot of Kepler in Deck recently, so this looks like even a better solution there for some of the things that we're trying to do. Yeah, any questions from the group? Yes. I guess a question that I had, this is maybe related more to your role. How often is it that the client gives you constraints related to the sort of mapping software that you have to use, or sort of requirements, whether desktop, mobile friendly, that sort of thing?
Yeah, so one thing about my current work is we work for a lot of different clients. And so we're a services company. So all of our work is project-based, contract-based. And so we'll come in kind of with a lot of expertise on how to build something. And we either help them formulate their requirements, or we're coming in to fix problems and things like that. So it really depends. Typically these days, it's a lot of web mapping applications. At LM184, we also do a lot of work with satellite companies in the private and public sector. And a lot of those people want things to work on a desktop, but in a web browser. So our responsive design sometimes won't even really be the top concern. So if you're doing features lists and feature sort prioritization of those features that the client's asking for, um, we'll usually reach for desktop and kind of get an MVP first and then grow from there. So typically these days it's technical requirements that align with this kind of I'll say aggregations is our go-to for the most part here and like what I talked about. And the tooling is typically kind of in that webGL kind of space. So whether it's maplibre, deckgl, those kinds of things, some CZ maps here or there.
Related question too. So obviously, we're talking a lot about visualization and taking data from a database and showing it in a application. How often are you including some sort of processing in stream of that rendering? Are you doing like you said aggregations, or are there more complex models going on in the background? How often does that happen?
Yeah. So if we can do processing ahead of time, it's always better, right? You don't want to wait on processing as much as you can. I will say, so the aggregations in I showed something called a film drop UI where we're seeing like some AWS open data, satellite constellation aggregations in a hex grid on the map. Those hex grids are actually coming from the underlying database. And then we're mapping to the H3.js library on the front end to make sure that those features that are returned are mapped to a grid aggregation or hex aggregation. And so, but most of that, like we're using a centroid to kind of lump things in together. So that centroid calculation actually happens in a pre-processing step. So when we're writing our data I mentioned stack catalogs, spatial temporal asset catalogs, metadata about data basically, that points to an asset, usually in S3, but it could be anywhere. And by asset, I mean that underlying image usually. And so generally that processing, that ingest pipeline is where that processing is happening, creating the geometry, spitting that image asset into an S3 bucket, and then writing any metadata about it. One of those could be a centroid if we need aggregations to work. And then our client can, in a much more lightweight way, just use that to visualize. Does that answer?
Yeah, it does. Thanks.
We have a question in the chat from Mike. HIPAA related data. I've used hexbins to map such data. Use anything else other strategy? I have not. So my answer to that question is I have not. No, but I'm sure that you could, as if you're trying to generalize it, is what I assume that you're asking there.
Yeah, I mean, it was sort of Department of Corrections data, and we ended up putting things into bins on it was, I mean, we even made this sort of like you were saying, a static map. Department of Corrections didn't want it to be, I guess, available on a website at all. So we essentially made a Word document out of it. But and then we could update the data through ArcGIS Pro, that type of thing. But anyway, it just we found that instead of using a heat map sort of obscured the actual density of it, whereas the hex bins seemed to work on a better thing. But yeah, it was the privacy issues that we dealt with in any case.
Yeah.
Just wondering.
I have not, but I would say I would imagine that would happen in a pre-processing step that you'd need to get everything out of there and then have a completely clean data set rather than doing it.
Yeah, it's just that when it's like you want to know where things are happening, but you don't want to oh, there looks, there's 5 dots. I know 5 people that live there, and there's one, you can sort of narrow it down to somebody who lives in a certain area. But anyway.
Yeah, no, for us, we do pre-processing. There's actually folks from my team on this call right now that are dealing with that exact problem, where we have to de-identify the locations of the points that we're getting to a certain granularity, depending on different legal requirements. They're always changing by state, and so if you can, get the right size XBin or other aggregation units, we want to do that ahead of time before we have to do any rendering and analysis on it.
Yep. See, raised hand. Go ahead.
Exactly.
Well, thank you for this really interesting talk, Brad. And I guess I want to, I really appreciated how much time you put into kind of thinking about multi-scale thematic mapping, right? And thinking about data representation sort of continuously through scale. And I'm kind of reflecting back to, I previously worked for Strava Metro, and so that's a fitness tracking application. And we partnered with departments of transportation and city planners to try to make sense of millions of GPS traces of like where bicyclists and pedestrians are going. And one of the approaches we used and continues now to be a research interest of mine is kind of thinking about like how can we take advantage of both raster and vector forms of data through scale. And so, I was just curious if you've done anything like, you think of a global extent and maybe you're using a heat map because it's really sort of cheap and quick to render. But then as you zoom down, you're transitioning to vector traces, right? And then you have all these sort of new potential to, look at attributes and that sort of thing. And yeah, I think at the time we were using actually Tippecanoe, and I think data maps was the precursor to that for raster tile creation. And obviously one of the challenges now I'm thinking about as a researcher is, how can you go through scale and make those representations look similar? Like you don't want the user necessarily to know you're transitioning between raster and vector, so you need design cohesion. But then there's also this element of interaction cohesion, right? Because like at a global scale, if you're looking at a raster heat map, you can't just click on it and get a value on demand. But then if you zoom in and it's vector, maybe you can. And so, yeah, I think I'm more just curious if you've thought about that at all or experimented with that sort of approach. And maybe it's less relevant now with these fast data servers. But yeah, just curious to hear your thoughts.
No, I think that's a great question. And I have thought a bit about that. I'd point to a couple different things. One would be that perceived performance kind of hack. And so at that initial load, you could load a very generalized data, right? Until you actually have time to render everything else in the background, and then you swap. And generally the user won't be able to tell that you've swapped, but they see that initial load, and that, as you know, probably load times are a big deal for users, right? And so leaving them cold with a spinner for, even 30 seconds is rough. And so if you're able to generalize that, that actually isn't that useful until you zoom in. And then I've done it in the past where we show a zoom message, even though, yes, you could see things there, but you can't interact with them. So you pop up a little, as long as you're letting that user know, like following the good Nielsen-Norman group heuristics of making sure you have that user feedback happening. And I will say also, like, combining everything that I talked about here is totally valid. So those hex aggregations, as you zoom in and then have your layers visibility swap off, right? There's no reason that you can't do that and make both of those work together really, really well. I certainly have done that, and usually you set, those zoom levels to be the same, one off, and then you come in and then you swap things over. It's always tricky because if you are doing like a raster at a low zoom level, then if it's a static raster that you're like, it takes a lot of time to create, how updated is that actually going to be? And the last thing that I'd kind of point you to a little bit is T-Tiler. If you're not familiar with that project, you might want to look that up. It's dynamic tiling, and that application using the hex bin, the film drop UI, Earth Search, AWS thing I was talking about. We start with hex bins at a certain zoom level, and then as you get in, we move to grid aggregations, because that more closely aligns with the satellite footprints that we're actually aggregating all these things against. And then once you get in even closer, then you see the individual scene footprints themselves. But actually on click of those, we're just showing blue box geometries at that point. Once you click and select one, we're passing that through T-Tiler. So we're taking the source of that underlying image asset, the actual image file itself, passing that through T-Tiler that runs in an AWS Lambda to do dynamic tiling and spit those tiles back to the client to render the image overlays into that scene footprint. So you can combine all of these things in really interesting ways. They're not just one, for each thing.
Awesome, thank you.
Another question. So you talked a lot about open source tools, which is awesome. I know for us, in our work, we're always trying to find things that are open source, Apache projects, and that type of thing. And you talked a little bit about cloud native. I've noticed that you've mentioned a lot on the AWS space. Have you done some of these different applications in different cloud platforms? And if so, like, do you have any suggestions, or can you talk about differences between them? Google, Azure being some of the bigger ones.
Yeah. So when we're at Element 84, we're an AWS partner. So I'll put that out there that like we talk about them a lot because we work with them on a lot of projects. We also have done some work with Microsoft Planetary Computer, which is in the similar vein of showing a lot of planetary scale data on a map at the same time. Under the hood, those kinds of things typically look the same when we're talking about cloud native. So it's really moving that processing and letting a user not download the thing. You're just moving the user up to where that data is. And so we're not having to download and wait for all of these data sets. You're doing the processing right there with the data, which is really efficient. So I think that that's generally similar across a lot of the big cloud providers, whether it be GCP, Azure, or AWS. I haven't touched too deeply into those. I know Planetary Computer is really powerful. I haven't done much analytics there myself. Let's see, Google Cloud Compute, you can do some things in. There's Google Maps engine. There's one there that I can't remember the name of. If somebody feel free to jump in. But there's Earth Engine. That's it. There we go. Google Earth Engine. That's the one on the Google side, which is kind of a little bit before these other ones as far as analytics go. It's a little bit more about executing code directly in that user interface. I don't really have much more to say other than they're all, pick your flavor and your tooling. That's kind of my opinion on it. I talk about AWS because we work with that a lot at my current place of work. That said, the open source part of me wants to come back and put everything to cloud agnostic and not be tied into one just because your data's sitting there. So,
any other questions from the group? If you not, I do want to give us contact information. So is it fair to say that feel free to reach out if you have
sure.
any additional questions?
Yep. Yeah, I've got my LinkedIn and email up that were in those slide decks, so it's in the recording. Feel free to look me up on LinkedIn, reach out. Happy to chat more.
And so this is the second of 3 talks this semester. So we're going to actually continue the data visualization theme. And on May 1st, we're going to have a hybrid map chat with Claire Trainer. She is a data visualization developer at Reuters. So we're going to be talking a little bit about visualization as it relates to journalism and some of the other work that she's done. So hope everyone can either attend in person or virtually to that on May 1st. I believe that's going to be midday as well. So with that, thanks everybody for joining and hope to see you soon.